The Galilean moons of Jupiter, four of the largest and most remarkable moons in the solar system, have fascinated astronomers since their discovery by Galileo Galilei in 1610. These moons, Io, Europa, Ganymede, and Callisto, are unique in their own right and offer an unparalleled glimpse into the diversity and complexity of planetary bodies. As Galileo observed, each of these moons revealed distinct features, behaviors, and geological histories, changing the way we view moons and their importance in the cosmic landscape. Io, the innermost moon of the Galilean quartet, is a volcanic marvel. It is the most geologically active body in the solar system, with hundreds of volcanoes and an ever-changing landscape. The heat beneath its surface is generated by tidal forces, primarily caused by the gravitational interaction between Io and Jupiter, as well as the other Galilean moons. This constant gravitational tug-of-war leads to immense friction within Io's interior, creating the energy necessary to fuel its violent volcanic eruptions. Some of these eruptions shoot molten sulfur and rock high into space, painting Io's surface with vibrant hues of yellow, orange, and red. The moon's atmosphere, thin and composed mainly of sulfur dioxide, is also a direct result of volcanic activity. Io's surface, constantly reshaped by these eruptions, is covered with plains of solidified lava, mountains made of ice and rock, and vast volcanic pits. Despite its harsh conditions, Io's dynamic nature makes it one of the most fascinating places to study in the solar system. Europa, the second Galilean moon, holds its own allure due to the tantalizing possibility that beneath its icy shell lies a vast ocean of liquid water. This moon's surface is mostly smooth, covered with a thick layer of ice that is fractured in a way that suggests it is floating atop a subsurface ocean. The cracks in the ice appear to have been caused by the rise and fall of tides, indicating that Europa experiences tidal forces similar to those on Io, although they manifest in different ways. Scientists have long speculated that the ocean beneath the ice could harbor the conditions necessary for life, making Europa a prime target for future exploration. The surface itself is a mystery. Although it's mostly covered by ice, there are areas that show signs of active geological processes. Plumes of water vapor have been observed erupting from cracks in the surface, further supporting the theory of a liquid ocean beneath. Europa is an enigmatic world, and the potential for discovering life in its hidden oceans makes it one of the most intriguing places in the solar system. Ganymede, the largest moon in the solar system, surpasses even the planet Mercury in size. Ganymede is unique among the Galilean moons because it has its own magnetic field, likely generated by a molten iron-nickel core. This magnetic field provides some protection from Jupiter's intense radiation belts, unlike the other moons. Ganymede's surface is a blend of older, heavily cratered regions and younger, less cratered terrains, indicating that it has experienced significant geological activity over time. Beneath its icy crust, Ganymede is believed to have an ocean of liquid water, though it is sandwiched between layers of ice and rock. The presence of this subsurface ocean raises questions about the potential for life in environments similar to Europa's, though Ganymede's distance from the Sun means it may be less likely to harbor life. Still, its magnetic field and the evidence of geological activity suggest that it is a dynamic moon with many secrets still to be uncovered. Callisto, the fourth of the Galilean moons, stands in stark contrast to the other three. It is the most heavily cratered object in the solar system, a testament to its ancient and largely unaltered surface. Unlike the other moons, Callisto does not experience significant tidal forces, and as a result, its geological activity is minimal. Its surface is a record of impacts, with enormous craters and valleys dotting the landscape. Beneath this heavily cratered exterior, there is evidence of a subsurface ocean, although it is thought to be much deeper beneath Callisto's thick, icy crust compared to Europa or Ganymede. Callisto's lack of volcanic activity and its relatively stable surface make it one of the most ancient bodies in the solar system, providing scientists with a window into the early history of the solar system. While its surface is old and scarred, it may still hold important clues about the early development of the moons and their potential for harboring life. Together, the Galilean moons form a remarkable group of objects, each with its own history, environment, and potential for future exploration. They highlight the diversity of planetary bodies in our solar system and underscore the complexity of the forces that shape them. From the fiery eruptions of Io to the icy oceans of Europa, the magnetic fields of Ganymede, and the ancient craters of Callisto, these moons offer a fascinating glimpse into the processes that govern planetary systems. As we continue to study these moons, both with telescopes and spacecraft, we uncover more about their pasts and their futures, learning more about the broader mechanics of the solar system and the possibilities of life beyond Earth. The Galilean moons are not only essential to understanding Jupiter's own formation, but also crucial in our search for life in the universe.